Over the last few lectures, we've been talking about client-side programming with JavaScript. And we have one more topic today that involves client-side programming. And then next week, we're going to start talking a little bit about the server side, how we can actually store persistent data and allow interaction between different users and different clients, different web browsers. So I'm really excited. Today, what we're going to talk about is drawing. But instead of using SVG, we're going to use a new JavaScript library, which is provided as part of HTML5 called Canvas. So up until now, we've been using SVG to draw our graphics. And SVG works really well. We said before, it's a really natural fit for HTML, especially HTML5, because like HTML5, it's markup based. We use tags for the different shapes. And so for loading static images, it's great. On the other hand, using it from JavaScript is a little bit awkward, because in order to use SVG objects, we have to manipulate the DOM, the document object model. We have to add and remove nodes. We have to modify the tree that represents the document object model. And so that's inconvenient. It would be really nice if instead we could just call drawing functions. We could say, draw a line from here to here. And that's what HTML5 Canvas is going to do for us. So in HTML5, they introduced this new object to the canvas, and we're going to learn some of its properties today. So like scalable vector graphics, the canvas object is going to allow us to draw things like shapes and paths and images. But instead of using markup, we're going to draw using JavaScript methods that are specifically designed for manipulating graphics. So we'll call it draw line function, for example. So to create a canvas object, we just use the canvas tag. And the canvas tag can take several different attributes. The most important ones are the width and the height. So I can set the width and the height right there in my HTML, or I can adjust them programmatically. That is, I can change them in the JavaScript. Similarly, my canvas object can have an ID. That's going to be useful for drawing, because I need to know which canvas to draw to. I might have several different canvas objects on the same page. Maybe I'm displaying different graphs and charts. For example, in the environmental science project that I'm doing, we might want to graph rainfall and also temperature on the same page. And so we might have multiple canvas objects to represent those different charts. So it's useful to be able to identify them so that I can access the object through the DOM. So in order to draw, we have to first get the object, and we do that using the same DOM functions we've used before. So I could use get elements by tag name, but if I do that, then I have to have a big array of elements and get the first one or the second one. An alternative approach is to use get element by ID, and if I've set an ID attribute in my canvas, I can do that. So if you notice back here, I set the ID in that last tag to page, and here I'm using get element by ID, and I'm passing in the page string, and that'll give me that canvas. And now I'm putting it in a variable named canvas, which is convenient and makes a lot of sense. The problem is I can't draw directly to the canvas object because it's a DOM object. It represents a node in the web page. It's not a drawing object. But every canvas object in the DOM has a function that you can call that gives you something called a graphics context. And a graphics context object provides the drawing functions that we want to use. So to get that object, we use the getContext method. So we say canvas.getContext. And notice I pass in a string, 2D. We'll talk about that in a minute. And what it returns is a graphics context that I can draw with. So here I have var ctx. That's where I'm going to store my graphics context object. And I set it equal to canvas.getContext of 2D. So we're going to use the two-dimensional drawing context, the 2D context. If you want to draw 3D shapes, you can. There's a programming language called WebGL, or really a library called WebGL that you can use. And there's two versions of it. There's WebGL and WebGL2. WebGL is based on OpenGL, which is often used for game programming. Any kind of three-dimensional graphics or modeling, OpenGL is a really good choice. It's kind of an alternative to DirectX, if you're familiar with that. We're not going to talk about WebGL. It's beyond the scope of this class. It's very powerful. You can draw some really impressive graphics. I think the Unity game engine can render to WebGL now, so it's pretty useful, pretty prominent. Once I've got my graphics context, my 2D graphics context, I can draw paths. You're going to see that a lot of the functions for Canvas are very similar to the SVG functions that we talked about before, the different elements of an SVG image. But they're going to be methods instead of tags. So in particular, I can draw paths just like I can in SVG. I use the move to function and the line to function. In this case, I'm going to move my pen to the point 50, 50, and I'm going to draw a line from 50, 50 to 50, 0. So that's the horizontal line. Notice that the image I'm drawing is something that looks a little bit like the coordinate axes. And it looks kind of funny on the slide. The lines are a lot smoother on my actual screen. And then I'm going to move back to point 50, 50 and draw a line to 70, 100. That's the line that kind of goes down and to the right. And then I'm going to go back to 50, 50 and draw a point to 0, 70, and go back to 50, 50 and go to 150. So I'm going to draw these lines. Now, it turns out those lines won't actually show up until I call this other function, ctx.stroke, which kind of tells the canvas that we're done drawing and to go ahead and render. We'll talk more about that in a few slides. So here are the methods that are related to paths. The first function is the most important. To begin a new path, I call begin path. It turns out that if you want to draw multiple shapes, you have to begin a new path each time, or the canvas object will treat them all like one path, and it will apply the same styling to all of them. So for example, if I want to have two shapes that are different colors, I have to call begin path before I draw the first one and call begin path before I draw the second one, or when I change the color the second time, it's going to change the color of both objects. If I want them to be distinct objects, I have to make them separate paths, and the way I do that is by calling begin path. Kind of confusing. The important thing is every time you start drawing a new path or a new shape, you call begin path, and that way the canvas knows that they're separate shapes. There's also a close path function. As with SVG, closing a path means I draw a line from the current pen position back to the beginning of the path. So it sort of just closes in the shape. There's a move to function that moves the pen without drawing. There's a line to function that draws a line from the current pen position to a new position, identified by the coordinates x and y. I can also draw curves from the current point to a new point. And just as with scalable vector graphics, there's two different kinds of curves, quadratic and cubic Bezier curves, which we just call Bezier curves. And the difference is how many control points they take. A quadratic curve takes one control point. A cubic Bezier curve, or a Bezier curve, takes 2 control points. You can also use the arc function, just like you can with SVG. There's actually 2 different ways to do arcs with Canvas. There's the arc function and the arc2 function. Everything I've read says to avoid arc2 because the semantics are confusing. It doesn't behave the way you think it does. So instead, you should use the arc function. The arc function takes an x and a y. That's the destination. Remember, it's going to draw an arc from the current point to the point xy. It takes a radius that tells it how much to bend the curve, a starting and an ending angle, and then a direction, which can either be clockwise or counterclockwise. 0 for clockwise, 1 for counterclockwise. Basically a Boolean flag. I mentioned before that creating a path doesn't actually draw anything on the screen. If you want to draw something on the screen, you have to tell the canvas that you're done with your path and that it should go ahead and render. And there's 2 different ways you can do that. You can call the stroke function, ctx.stroke, and that'll draw the path as an outline. It'll just draw it as a sequence of connected line segments or curves. You can also call the fill function, ctx.fill, and that will draw your path, and then it'll fill it in. It'll do a flood fill, basically, within your shape, creating a filled shape. So for example, if I draw a triangle and I call stroke, it'll draw an empty triangle. If I call fill, it'll draw a filled triangle. No big surprise there. I can also draw shapes with SVG. Shapes in SVG are generally considered paths. So a shape is a path. That means that if I draw a rectangle with the rect function, it's going to actually draw a line to the top left corner of that rectangle from the previous point. So if I want to draw just a rectangle and not have this line connecting it to my previous shape, I have to call begin path to start a new path. And then I can draw my rectangle, and it will be independent and not have this weird line connecting it. So to draw a rectangle, I can use the rect function. It takes the x and y coordinate of the top left corner. It takes a width and a height, and it creates a path containing a rectangle, which again doesn't show up until I stroke or fill. I can also draw an ellipse. If I draw an ellipse, I specify the center of the ellipse as an x and y coordinate. I specify rx and ry, which are the lengths of the radii, of the axes. So rx is the length of the x-axis, ry is the length of the of the y-axis. An angle of rotation, which tells it how much to sweep out, basically, a start and an end angle, and a direction, which tells it whether it's clockwise or counterclockwise again. There are actually some shortcut functions here for drawing rectangles. SVG provided lots of shapes, but in Canvas, the only non-path shape is the rectangle. Everything else is a path. The only way to get an ellipse is to use the ellipse function that draws an ellipse as a path. But I can draw rectangles as shapes rather than as paths using these three functions. The stroke rect function draws an independent rectangle, a rectangle shape, with top left corner at XY and with a given width and height. And it strokes it automatically. Because it's not a path, it just draws it right there. Again, it's an outline of a rectangle because it's the stroke rect function. I can create a filled rectangle with fill rect, which takes the same parameters and draws a filled rectangle. Again, it's not part of a path, so it just draws it. There's also kind of a unique function, clear rect, that draws a rectangle, a filled rectangle, but instead of filling with the current color, it fills with the background color. So this is a quick way to erase. Typically what you do with clear rect is erase your entire canvas, your entire screen, by putting 0, 0 in for your x and y coordinate and putting the width and height of your canvas object in for the width and the height. So that'll erase everything in the canvas. If I want to set the color or the stroke properties, I just set variables in the graphics context. So there's a variable named ctx.strokeStyle. Notice the use of camel case here, the capital S for style. I just set it to the color I want to fill with or the pattern or the gradient name. I can also set the fill style if I want a filled shape. And when I call the .fill function, it'll fill with this color or pattern or gradient. I can set the line width property to get thicker lines around the border of my object. I can also set the line cap and line join properties. Line cap determines the shape of the end of a line. So if I have a line of maybe width 5, I could either have a flat end or a square end, or I could have a rounded end or a kind of a beveled end. And so if I set the line cap property to round or square or bevel, I'll get the appropriate line endings on my lines. Line join has to do with where two lines meet. That's usually the corner of an object. When two lines meet, they can either form a sharp corner or a rounded corner or what's called a mitered corner. That means that where they meet is kind of at a cut off, like at a slant. So that looks a little bit better some of the time. So you can choose those two properties if you care about the shapes of your lines. As with SVG, we can draw text. The fill text function is really easy to use. You just say .fillText, ctx.fillText. You pass in the string to draw, and you give it the x and y coordinates, I think, of the top left corner of the line of text. And so here I've drawn the text example at coordinates 10, 10. And so here's the word example in filled text. I can fill most shapes. I can also stroke most shapes. Text is no different. I can stroke text. So I can say ctx.strokeText, pass in a string, tell it the x and y coordinate, and it'll draw like this. Notice it gives me kind of an outline letter, kind of a block letter shape. That's useful for certain kinds of effects. Just as I can set the color and the line width properties, I can set the text properties. So I can set the font. I do that by setting ctx.font to some sort of string. And the string is a CSS font string. So I could say 24-point sans serif, and that would be my drawing font. I can use the text align property to center text horizontally, or to left or right justify it. I can also use the text baseline property to center my text vertically, or to glue it to the top or the bottom of the line of text. I can also draw raster images using Canvas, just as I can with SVG. It's a little bit more complicated, though. If I want to draw an image, it has to already be loaded into the web page. There's a couple ways we can do that. The easy one is to put an image tag in the document. And then the image will load naturally as the page loads. A common trick is to load the image but set its width and height to 0 so it doesn't actually show up in the page. It's there, but it's invisible. Then when I want to draw it into the canvas, I can call the drawImage function, passing in the image, an x and a y coordinate, and changing the width and the height so that it's no longer 0, 0. And now it'll show up in my canvas. So one way to do this is to use the getElementById method to get the image tag that I've already loaded, the image I've already loaded in the document, and use drawImage to render it into my canvas. I'll point out width and height are optional. Because the image has to already be loaded, it has a default width and height. And if you omit the width and height parameters from drawImage, it'll just use those values. An alternative is to load a new image into the page using JavaScript. To do that, you create a new image object. So I can say var image gets new image, in two empty parentheses. And then I can set its URL by doing image.src and set that to some URL. So maybe http://marmerstein.org/twiddlerobert/pic.ping. I could set that URL as a string. And then I have to wait for the image to load. So once I create the image and set its source attribute, the web browser is going to try to load that image, but it's going to take some time for it to download possibly. So I have to wait until it's loaded before I try to draw it. Conveniently, an image object has an event function that I can set. I can set the onload function, just like I have onload in a body or any other HTML element. And when the image has finished loading, it'll call the function. So here I'm setting an anonymous function to be the onload event for the image. And when the image has completely loaded into the web browser, it'll call draw image and draw itself into my graphics context at position 1010 with default width and height. I can also perform transformations on the shapes in my canvas. As with SVG, I can perform translations, rotations, and scaling. To translate, I just use X and Y. It's important to note that when I translate, I'm translating all the objects from that point out. So if I translate and then draw, everything's going to draw translated. Similarly, if I rotate and then draw, everything I draw from that point out will be drawn rotated. If I scale and then draw shapes, they're going to be drawn at scale. So every time I call scale, I'm changing the current transformation matrix, and it will remember that and apply it to all the objects I create next. Which is why Canvas provides two additional methods that we didn't see in SVG. And these are the save and restore functions. Save saves the current graphic state to a stack. And we can call save multiple times, and it'll kind of remember what the graphic state was. This is sort of like having an undo and redo history. So we can sort of remember the different graphic states we've had, and then we can go back to them as we need to. What is a graphic state? Well, the graphic state includes the color of the stroke and the fill. It includes the current line width. It includes the current font and text styles. But it also includes the current transformation matrix. And so if we have told it to rotate everything 30 degrees, we can save our graphic state, do the rotation, draw some shapes, and then restore the state. And now when I draw, it's not going to be rotated anymore. So I can draw certain things rotated and then stop rotating by restoring the graphic state. This is really handy, but it's kind of tricky to get used to it first. It takes some practice to learn to really use save and restore effectively. Another thing I can do with my canvas is copy and paste a section of the canvas. So I can use getImageData to copy a selection, a rectangle, from the canvas, and I can store it in a variable. So here I've created a variable named clone, and I've called getImageData from coordinate 0, 0 with width and height 20. So it's going to copy a 20 by 20 square from the top left corner of the canvas, and it's going to store it in the variable named clone. Then I can paste it back into the image in a different place. So here I've done ctx.putImageData, and I'm putting the clone at position 0, 20. So it's going to have a copy of what was in the square from 0, 0 to 2020 right next to the new version. And then I'm going to put the image data below the original one too. So I'm going to have 3 copies of that same graphic, one in the top left corner, one to the right of it, and one below it. In other words, I was able to copy and paste it, and when I paste it, I can paste it twice in different positions. So in summary, HTML5 provides a wonderful canvas object that lets us draw directly to the canvas with JavaScript methods. We can create a canvas by adding the canvas tag to our HTML. In order to draw to it, we have to first fetch it using DOM methods and then call the getContext method to get a graphics context object. We can then draw using paths, which don't show up until we call either fill or stroke, or we can draw rectangles with stroke rect and fill rect. We can draw lines, we can draw arcs, rectangles, ellipses, we can draw text, we can also embed images. So I hope that you'll find this useful in your glitter for Lab 3. I hope that you're working on that. I was impressed with your Lab 1s for the most part, and I hope that Lab 3 will be equally impressive. Please take your time and work on these labs because they are difficult, I know. Next week, we're going to start talking about server-side programming, which is exciting. We'll be able to make our pages more interactive, and we'll start working our way towards some of the modern frameworks like Flask for building more complex and comprehensive websites. I hope that you have a great weekend.